Before the 18th century, the subject of electricity and magnetism were thought to be different. It was in 1820 that Hans Christian Oersted, a Danish scientist, discovered the connection between these phenomena. During an experimental demonstration on electricity, he observed a noticeable deflection in the magnetic compass needle placed near a current-carrying conductor. Let us understand the experiment. In the first case, a magnetic compass is placed below a straight conducting wire with the length of the wire in the north-south direction. The magnetic compass is also in the north-south direction when the current is not passing through the wire. If current passes through the conductor in the south-north direction, the magnetic needle deflects towards the west. In the second case, if the direction of the current is reversed and the current is now allowed to pass through the conductor in the north-south direction, then the deflection in the magnetic compass needle placed below the conductor is towards the east. In the third case, the deflection of the magnetic compass needle can also be observed by placing the magnetic compass above the straight current-carrying conductor. If current passes through the conductor in the south to north direction, the magnetic needle is deflected towards the east. In the next case, if the direction of current is reversed and the current is now allowed to pass through the conductor in the north-south direction, then the deflection in the magnetic compass needle placed below the conductor is towards the west. All these situations were observed when the current passing through the conducting wire is large and the magnetic needle is placed sufficiently close to the wire so that the Earth's magnetism may be ignored. It was also observed that when the magnitude of current passing through the conducting wire was increased, the deflection of the magnetic needle placed at a constant distance from the conducting wire increased. When the magnetic compass moves closer to the conducting wire for the same amount of current passing through it, the deflection of the magnetic needle increases. In another demonstration, the magnetic field due to a straight current-carrying conductor could be found by placing a cardboard in a horizontal position and passing the conductor through a hole at its center, such that the length of the wire is perpendicular to the plane of the cardboard. Some iron filings were sprinkled on the cardboard. As soon as the current passes through the conductor, the iron filings orient themselves in concentric circles, with their center coinciding with the center of the conductor. From these observations, Oersted concluded that current in a conductor produced a magnetic field around it. He also found that the alignment of the magnetic needle is tangential to an imaginary circle with straight current-carrying wire at the center, and the plane of the imaginary circle is perpendicular to the length of the wire. To represent the magnetic field produced by a straight current-carrying conductor, on paper, we adopt the convention for magnetic field emerging out of the plane of the paper, which is denoted by a dot. The magnetic field going into the plane of the paper is denoted by a cross.